Oh, yeah. One more thing. If you're out there and you would like to be on this wonderful program, Show and Share, if you got something cool, you want everybody to see it, or you've got something that was like started out as like a really great idea and then somewhere it kind of went sideways, we would love to see it and like enjoy the process all together. Please send us a line at this great address here, and we will get back to you and put you on the show. Alrighty. Well, today we have kind of a full lineup, starting with Adam W. with the car audio upgrade. Tell us all about this upgrade.
Okay, really? Sorry, my fiance Nada is here next to me, and she is secretly a 7-year-old. Anyway, so there should be a slide before this one. Was there not?
This is my first one. Maybe it's
okay.
after. Is
Nope.
This it? Nope.
Okay, well, we'll just go back and I'll wing it. It's okay.
Alrighty.
So this project started because the radio in my Mazda was great when I bought the car, but then my Bluetooth decided to stop working, which is pretty much the biggest thing I use in that car. I've done about a dozen or so radios installs like this, and I finally got tired of the Bluetooth not working, and I was just like, you know what, I'm just going to go ahead and replace it. And since I'm in Knox Makers now, I figured maybe you guys would be interested in seeing the process of what replacing a car radio looks like. So my first slide originally was my order that I placed on Crutchfield because I forgot to take a picture of everything before I unboxed it and put it all over the place. But I bought an Alpine radio, which you'll see in a minute. And this particular car has a special module you have to hook up in order to make the steering wheel controls work and a few other things. So this right here, what you're looking at is step one. When you buy a radio, it's going to come with a wiring harness, which is the little black thing just to the left of center with all the wires coming out of it. And you have to match that up with, down a little.
This thing.
Well, up a little to the right. That one right there.
This one?
Nope.
Right.
You had it left.
This
right
one.
there, that.
Okay.
So that's what comes with the radio. That plugs into the back of the radio. And then that kind of reddish one just to the right of that, the big red one. Mm-hmm. This is a matched wiring harness that is designed to plug into the car's system. When you buy a radio replacement, you need to get a wiring harness adapter, unless you like cutting wires in your radio and ruining the factory system. I'm a staunch supporter of wiring harnesses. So putting this together is relatively easy. What you're going to do is if you look really close at that little black connector, you'll see that the wires are in color pairs. You've got a green pair, purple pair, gray pair, all that. So those all those wires are color-coded to match up with the wires on the harness to the right. So if you look, there's a green pair there, a gray pair, a white pair. And basically all you do is you twist those wires together. And I like to solder them to get a good solid connection. And put on some heat shrink tubing or electrical tape. If you go to the next slide, you'll see the whole system all soldered together and wired up. It's kind of a rat's nest. So what we're looking at here is the red plugs into the car. The black one just to the left of center there, the squarish one, plugs into the radio. That silver one on top of the stack is the antenna that plugs into the radio itself. That little black module is the steering wheel control module. And that's, I think that's about it. So if you go to the next slide. In addition to the wiring harness, you also have to have a physical adapter to fit the radio into the car. On the Mazda, it's a pretty simple adapter. It's just this little frame and then these two little wings. And if you go to the next slide, you'll see it fully assembled. So there that is put together. And you see the radio in the back waiting, thinking soon. So the radio just pops in with a couple screws, which you'll see on the next slide. And there it is. There's the radio ready for install. So now, if we advance the slide, I think we'll be going out to the car now. Yeah. So I planned to do this during the day, but that didn't work out. And I also forgot to take a picture of my dash before I removed that trim panel. But basically what you're going to do is you're going to remove whatever trim panels are necessary to get to the radio. Most of the time they just pop right out. I've seen sometimes they have a screw or two, but usually you just pull on them and they come off. And then the next slide will pull that other piece of trim off there. So here's the radio, the stock radio completely naked. And you see there's a screw to the right, there's a screw to the left. I took those screws out and then fought with it and couldn't figure out why it was stuck in there like that. And if you go to the next slide, you'll see this stupid little screw hiding in the back that I didn't have a screwdriver for because everything else was Phillips and this one was a hex. So I had to go and cobble something together, and it took me 15 minutes to get that stupid screw out because my socket set was didn't have an extender bar long enough. But at any rate, go to the next slide, please. Okay, so one of the things we have to do with this radio is we have to hook it up to the factory Bluetooth module. That's so that the steering wheel controls will work. And here I've got my glove compartment removed. It just presses in from the sides and then just pops right out. It's super easy. And then the next slide, you should see my actual Bluetooth module, which is kind of up and inside on the ceiling there. That's just inside above the glove compartment. Now the directions, I think I put a picture of the directions up next. There we go. So the directions that come with the steering wheel controls show you how to wire it up. And if you're really astute, you may notice a little red box at the bottom that says tap the blue wire from the module to the pink wire on the harness. And now if you go through the next 3 slides, you'll see that there is no pink wire. Yeah, go ahead and advance. So there's no pink wire anywhere on this connector. And as it turns out, the instructions were written for a slightly different model than mine. So I ended up having to contact support to find out what to do. And as it turns out, I didn't need to remove my my glove compartment at all because my connector is actually on the factory harness. So if you go to the next slide, should be our support email. Devin, who was very helpful, showed me that on his connector there's no wire, but on my connector there is. So if we go to the next slide, we'll see hooking that up. So I don't like to tap into the factory wires just because it lowers the value of the car and makes things a mess later on. So what I did here is I took a piece of solid copper wire, stuck it into that port, and then just ran it outside of the harness. And then on the next slide, you'll see it all put together, and I've tapped onto that wire. So that way we don't have to make a modification to the factory system. And then next slide. Okay, so here's the rat's nest all put together, and it looks terrible, but this radio is way smaller than the stock radio that came in this car. So there's lots of room behind it. So normally I like to tidy things up and tie them up, make them all nice, but I had so much room here, I just didn't care. So I just shoved it all in there. So next slide. So here we've got the radio installed and working. All I've got to do at this point is screw it into place. The orange wire that's tied up and hanging below it is for the dimmer controls, which the car supports, but this radio doesn't use, so they just get tied off. Next slide, we should see it all nice and buttoned up. And there it is, all put together and upgraded, and it works spectacularly. So that's it.
That's awesome. And it's definitely a lesson in like I know that there's all that stuff crammed in there in the car, but you never see it. I don't even think about it. There's a lot in there. That's a lot. It seems like that, is quite a task.
This one was a little bit more than normal. I actually I didn't show it because it was super embarrassing. But when we went from night to day right there during the pictures, that was because as I was pulling the radio out, whoever installed the radio at the factory, they took the cable and wrapped it around another cable by accident and didn't bother to fix it. So when I pulled the radio out, there wasn't enough slack in the antenna line. It actually broke the antenna connector in the car. So I had to spend some time taking that plug out and fixing it up. And in one of the pictures, you can actually see it in the background, zip tied together. But it's just antenna. It doesn't carry power, and it works fine, so it doesn't bother me.
Oh, well, that's awesome. And a good catch, too.
There we go.
Alrighty. Now we have Andrew with the nearly Pry Remedy. You're gonna have to help us out here with that one. That's a heck of a title. Oh, you have an audio issue. We can't hear you.
Oh, whoops. How? Is it, we good now? Yeah, it's nearly free Wii Remedy, which is quite a title. Thank you, John Dale. So here's the deal. I was at McKay's selling some books because reading's for fools. And they had some random electronics that I was like, oh, I'll just use my trading credit for that. And one of the things they had was this Wii balance board here, which I don't know if you remember these or not, but you're supposed to get on them and do yoga.
Oh yeah, we got one.
Yeah, everyone and their mom had one of these things, and as a result, they're incredibly cheap, but they're full of all kinds of great technology. So, and I did a little bit of research on this. Like, apparently, there's been a lot of like nursing homes and stuff like that that have used these things to replace like several $1,000s worth of equipment for like balance testing and things like that. So it's designed to pair via Bluetooth to the Wii, but it uses kind of like a pseudo proprietary implementation. My guess is that the Wii and the balance board like have a handshake that's already pre-programmed in the firmware, so it doesn't have to ask for a pin or any of that other crap. As a result, the way that you pair this thing to a traditional Bluetooth device is by pushing this button, which is located like right there. Okay. And that's underneath a battery cover. So I found a couple guides online for how to make that better. One of them was suggested that you use like a pencil and some foam pads and some tape. And so you just like hang the pencil off the edge of the thing, and then you can kind of kick it, and that'll push that button. And that was supposed to be the hack, which I thought was insulting because I don't know. If you're gonna pretend like you're doing any hacking, at least bust out a soldering iron. So if you want to switch over to the next image. So this is the circuit board that button is attached to. To the left of the button, which is the red thing there, you'll see a little orange yellow I don't know, surface mount component. That's a fuse actually. So I got to the makerspace. I was gonna just really quickly do this, and I forgot batteries for the thing to test it. So I was like, well, I'll just be smart and I'll just hook it up to the DC power supplies that we have there. And so I hooked it up, thought everything was correct, gave it 6 volts because it uses 4 AA batteries, and that's that number, at like half an amp, and it just wouldn't work. It stopped working. And I was like, great. So I went and got batteries, shoved them in there, and it still wasn't working. And the reason for that was because that fuse had blown. I don't know exactly how I did it, but at some point during the process, I must have crossed wires some way. So my first step was to get it back to the working order that it came in. So if you want to go to the next slide. So with way too much flux and just enough solder, I managed to get a fuse of the same rating soldered into there. And shockingly, this works, which is, I don't know, an unexpected result for sure. Anyway, so I got it back to its working status. My real goal, though, was to take the wires coming off of this switch. If you want to go to the next slide.
Wires.
Coming off of this switch here, and I was going to bridge those onto the only other interface this thing has besides the fact that it's a scale, and that's a button in the. Sorry, go ahead.
This is on the other side of the board, right? This is the back side.
Yeah, that's the back side of that. So okay. the red thing is now underneath those 2 wires that are soldered there.
Right there.
Yeah. And so so the only other button that the device has is on the front, and I think it like turned on the switch if the switch was in, or sorry, not the switch, the Wii was in sleep mode. Then it would like power the thing on, so you didn't have to like go behind your TV and push buttons and stuff like that. But I tested it, and if I mashed both those buttons at the same time, it would still go into the sync mode that I needed. So what I did is just jumpered it straight off of that button here. If you go to the next slide, to this push button on the front, And this was pretty easy. I just literally just shoved those wires into that harness because there was a little bit of a gap around where the wires managed to meet. And now when you push this front button that is designed to be kicked or whatever, and not like underneath a piece of plastic and everything else, you can hit it no problem. So I got everything together. I buttoned everything up, which it's like 14 or 18 screws to put the back on top. And I flipped it over and I tested it, and I had lost about 25% of my weight, which is fantastic, except for the part where like I didn't do anything. The reality is that if you go to the next screen or next slide, I had managed to screw directly through one of the signaling cables that goes to the 4 sensors on the outside here. So luckily I was able to figure that out pretty easily. Yeah, that was pretty rough. And so I just stripped those back, wired them together, put some solder on it because why not, and a little bit of electrical tape, and made sure it was in the right place. And I don't know if there's another slide now. I think that's it. Yeah.
You're correct.
Anyway, but I put it all back together, and now it's working-ish. So the next project was to grab a Raspberry Pi and set up a little Python job that somebody did most of this work for me. But the Python basically just like opens up a Bluetooth connection asking for sync. It looks for this device specifically, or this type of device. And within 2 seconds, if this is going and the script is going, then it'll pair it. So it takes almost no time to pair. And then after that, a little bit of additional code I added to it was to take the weight that it gathered off the end and ship it to a CSV file. From that CSV file, I don't know what I'm going to do with this information, but that was the weekend project, was to at least get that data out of the system. So that's where we're at right now. But yeah, these things are surprisingly robust and like super, like there's a lot of technology in this thing, and it was, what did I pay, $4 for it? Yeah, $4.95. So, and in reality, that was just some old books that I didn't want to read anyway. So, if you ever come across one of these, you should pick it up and do something cool with it. That's it.
Well, that's a pretty good deal.
Very cool. I'm gonna have to go up into the attic and find mine.
Yeah, go for it.
All righty. Well, now we have David with a sewing machine base.
All right. Well, I wanted to do, well, I got a sewing machine at a garage sale for $10. It was a 1934 Model 15 Singer, which in October of that year, just an interesting fun fact, they issued 35,000 serial numbers that they were building of that particular model. In December, so 2 months later, they issued another 35,000 serial numbers. That's how you can find out what model and everything you have, because there's a serial number right on it, and you can look it up. But it's just amazing that in 1934, they were producing 35,000 of them at a pop, and 2 months apart each batch. They had other models that they were doing. But anyway, I got this sewing machine, and one of my other sewing machines has a wooden base that you just sit the machine in, because the machine was made to go in a table, and you can drop it into this base, and it gives you a nice platform just to tote around and use. And so I thought, well, I'd like to make one for this old Singer, which was originally a treadle machine, but I didn't have the treadle with it. And so I decided on a kind of a hefty box, doing it out of cherry. And then I thought, well, I'd like to do an inlay on it. I've never done an inlay before. So in this slide, you see that I've got some wood glued up. This is just a simple glue up with some scrap wood. I've got a couple oaks in there, cherry, walnut, maple, and poplar, I think, are the main woods in there. And it was just random, glued it up, and then made it into this chevron pattern. On the next slide, I also took some of that same wood and glued up strips, so that it was, at the time I glued all of this up, I really wasn't sure how I was going to use it. I just thought it'd be neat to do some different types of glue ups. In fact, I probably came upon the idea of doing an inlay after I'd already done this glue up. This glue up was something that I was doing just because I wanted to play with doing random glue ups, and then I decided on the inlay. In the next slide, you see that I've got the chevron pattern paired with the strips, and so that's what I ended up cutting out to make my inlay for this cherry box. On the next slide, you'll see the strips. What I did is I glued it all up, and it ended up being about a 1/2 inch piece of just a board with the little strips on the end and the chevron pattern down the middle. And then I cut it on our big bandsaw there at the shop with the big giant 3-inch blade, which is really nice. Cut it down into 5 strips. I only needed 4 of them, but I wasn't sure how thick it needed to be and everything. I would have liked to have had them thicker. I would have liked to have ended up with just 4 strips instead of 5. That way I would have more thickness to work with if I had to do a lot of sanding to get the sides to match up. And so I got that glued up, and then in the next slide you see where I did the inlay, and I just did that on my box. I took it to the router table and routed out a channel that the inlay fit into, and so that's just glued in there. And then the next slide, I've got just a little more detail on the picture of the glue up. So I was very pleased. I got a good tight joint between the inlay and the box. And then I just took some cherry sawdust and mixed it with some glue and coated everything with it so that it fill in any of the gaps that I had. And then the next slide, I happened to have some really dramatic lighting going on. And so here's the box with the nice inlay in the front. And this is my first time to ever do an inlay project. So the biggest thing was I was playing with inlay, and whether I ended up with a nice looking box, that wasn't that big of a deal to me. But the box the sewing machine fits in there. And I've got some other plans for what I'd like to do in the future with it. Next slide is another, just happened to have some weird yellow light coming in the window, and which with all the colors in there made it look really cool. So that's the box. I think I had a coat of polyurethane on it by then. I now have 8 coats and still not pleased. So I'm still working with the final outer coating, but I did put boiled linseed oil on the box to make the colors pop. In the earlier pictures, you saw all the colors were kind of muted, and now the colors are brighter, and that's because of the oil that I put on there. And then the next slide, you see the sewing machine in the box there. And so that's the old Singer. I don't know that I'm going to do much to try to clean up the sewing machine. And I'm doing the box more just to have a place to put it and make it look nice sitting on a shelf. The machine works perfectly fine. It's well lubricated, but it's certainly not pristine, and it's not worth anything other than, well, I think it's worth a little more than the $10 I paid for it. If it wasn't, I wouldn't have paid that much for it. But it's not anything really special. Making 35,000 of them per batch means there's a lot of these out there. But it does seem to work fine. And so that's the front of the machine. The next slide, you'll see the back of the machine, and you'll see there's those round hinges. I used a Forstner bit and made the holes for that to fit in. What I would like to do ideally is to take the machine now with those hinges, it can tilt back. And I'd like to make a little mechanism where I slide something and it'll lock the machine in place. But the bottom of the machine, there's nothing really to hook onto. So I'm trying to just figure out some ideas there. I've got some different ideas. So that's the end of those pictures, but I do have the box here and show you some of where the hinges go into these holes here. And that was done with a Forstner bit, but then I had to chisel out all this other stuff, which I haven't really ever done much chisel work. So that was a fun little part of it. And then chisel this out here. And then I just used a rabbiting bit to get the channel for the lip of the machine to sit into. So I'm pretty pleased with the way it's turned out. I don't like, I didn't want to do polyurethane. I wanted to do a spray lacquer, but I didn't have any spray lacquer and I had polyurethane. And so that's what I'm doing on it. And I've gotten some sanding marks in there. You know, you sand between coats. And so I've got to work on getting some of that out. But I've been pretty pleased with the project. And again, it was to learn how to do an inlay. And I feel like I kind of understand it. I made some mistakes along the way and cleverly hid some things that nobody will ever see, and I don't have to tell them. So it's been a fun project, and we've been talking about it at the shop for the last couple of weeks because that's all I've been working on. But that's my sewing machine box.
It's really beautiful.
Yeah,
Thank you.
that's awesome. I would say if you were doing that to, learn how to inlay, you nailed it. It looks great. It really does. I am curious though, you said that was a treadle machine. How do you get it to work without the treadle?
Just by
turn it?
hand.
Just
Yeah.
by hand?
And I say it works. All the mechanism moves the way it should, but I haven't actually stuck thread in it and made sure that the bobbin is spinning properly. The bobbin does spin, but I haven't actually tested it. But it seems to be everything is fine.
Oh, well, I know that there were older machines that would have like a little knob on the side of that wheel there so that you could turn them
With it.
easily.
Hand
If you
crank.
ever wanted to adapt it, that could be like, another direction you could go in. But
Right.
as
I've
far
also
as
thought-
the box, it looks great.
I really want a treadle. I would like to have a treadle, maybe not for this. I'd like to have a treadle to build a lathe off of it, just for a fun little lathe project. Sue said the box doesn't look like it weighs very much. It's pretty beefy with the with this cherry. That cherry in the back here is 2 inches, and the rest of it is almost an inch around. So it's a pretty heavy box. It doesn't weigh as much as the machine, but almost. So I think it's a pretty good base for it. I have thought about putting some kind of handles on the side here, just 2 little handles to help me pick it up. But I don't know if I'm going to do that. It's one of these things that I might take to maker fairs just to have sitting on a table to show off, but not anything that I'm really going to use. It was a project to learn how to build a box with a inlay.
Ryan asked if it would be a good idea for the box to be heavy, I guess as a counterbalance for the weight of the machine.
I think
That's
so. You're not going to ever get it as heavy as the machine, which would be, I would guess, ideal, having as much weight lower as you can. But I would think you wouldn't want it to be super light either. But the machine itself, it's so heavy that it's not going to get accidentally tipped over.
Oh, well, that is really awesome. Thank you so much for sharing that with us.
Well, thank you. I've been gone for a few weeks and I was excited. I've got a ton of projects that I've done over the last 6 weeks or so that I've been out and traveling, and so I may be back a few weeks in a row here.
Oh, I think that would make
We hope
John
you are.
and Tracy very happy.
Very good.
And
All
the
right.
rest of us too.
Thank you.
All righty. Now we have Keith and Erno's footstool. Am I saying that right? Erno?
That's right, Erno.
Oh, thank
Erno.
goodness.
Erno Rubik in particular.
Ah, okay.
So this is what we made. It's an ottoman that's 15 inches. It's 15-inch cube, and it is a giant fuzzy working Rubik's Cube. So you can see in the background here, we have it not scrambled at all. And in this picture, we have just a simple X design on it. And so if you go to the next slide, you can see more about how it works. So this is just what it looks like without the carpet on it. So each of those is a finger jointed box that's 5-inch cube. And so inside of this box, there's sort of a sphere shape. And so that's what really makes it able to turn. So if you go on to the next slide, you can see sort of an integral cross with these turntables on it. And so you can also see sort of a sphere shape. And so there are bearings that you can see. For example, there's in front of the cross, there's one in the corners, there's a bearing. And so those are inside the sphere, but attached to the individual pieces. And so those hold everything together, but still allow it to turn. And so if you go forward another one. These are each of the 3 different kinds of boxes that there are. So there are 6 faces, 12 edges, and 8 corners. And so you can see on the face one where that's sort of the sphere that's cut out of the overall box. And then additionally, on the edge pieces, there's the same type of thing, whereas the corner pieces have just the bearing that sticks in, and the edge pieces have the extra bearing. And so you can go forward another one. So it's a sphere, but it has to have some sort of structure to it. Otherwise, it would all just pop out. And so this is the integral cross that holds everything together. So, do you want to talk about this part?
Yeah, it's just a cross that we put together. You do a 2D, and then we drilled a hole through the center and mounted the other 2 arms. So pretty simple. If you could advance to the next slide. And that's with it, without all the corner pieces and edge pieces. The one thing on top is different, as you notice, and that's actually so that's the last piece that you put together. And that little silver disc is a 90-pound pull magnet. So that's how you put it together, and it takes some doing to get it off, but you can actually pull it apart when you need to. Okay, next slide. Okay, just more semi-assembled. Next slide. Okay, so this is actually what it looks like without that cross piece in the middle. And you can really see this. We included this so you could really see the spherical aspect of it. One more slide. And this is just that first layer, and so you can see all the different parts. The black parts are attached to the corners. The white parts are attached to the edges, and then the very thing in the center doesn't have any plastic at all. That's just the face. All right. Next. Getting a little bit into the assembly. All the plastic bearings were milled out of high-density polyethylene, both black and white. We just happened to get some, and this is the corner pieces assembled. Next slide. I think this slide and the next one as well are the setup on the CNC we have. And we modeled everything in using OpenSCAD to create STLs, and then we used MeshCam to do the cam for it, to create the tool paths, except for the real simple 2D things. For example, the MDF holding jig there is just a real simple 2D assembly that we use something called Heek CNC to carve out. It was a custom assembly or custom holding jigs. We also had a custom assembly jig that I don't think we captured in the sequence. Okay, next slide. And these are all of the finger joints. So I just calculated while we were waiting to start, and there's 2,400 finger joints. So this is basically a full 4x8 feet sheet of 1/4-inch plywood, just birch plywood, that we sectioned off into 5-inch by 5-inch pieces. And then you go to the next slide. Okay, and this is actually a jig that we made to do the finger joints. And this uses the same concept as you can buy them commercially, and any woodworking magazine would show you how to create a finger joint jig, but they always make it for a single board. This is a sled version of that where you can actually load up. I think I got up to about 30 pieces and was able to do them all at the same time. So it really made it quite a bit faster to do the finger joints. All right, maybe. Yeah.
Okay, so I'll talk about the carpeting. So we started off with, it was about a 3-foot by 5-foot sheet of it was just an area, white shag area rug. And so I cut it up into 6 large squares and then cut one of those large squares into 9 smaller squares. And so that makes up the white ones, and the bigger squares are the other colors. And so if you go forward a slide, you can see the dyeing process. So we used acid dyes and just on the stove because you have to keep it pretty hot, almost 200 degrees. And so that's why there's a candy thermometer in there. And so you basically just move it around in there for half an hour, and the dye, the shag absorbs the dye, and you end up with a yellow sheet of carpet in this case. And then I cut that up into the smaller pieces. If you go forward one more slide, I believe it's, yeah, so this is after all of them have been dyed and then cut up. And so
We call this the I Scan the Muppets slide.
Yes, Cookie Monster, Big Bird, Elmo, Oscar, and I don't know white and brown Muppets, but they're Sesame Street characters. But it was a lot of
Yeah,
tough stuff.
snuffle up against there.
There you go.
White and brown.
And so after this, we used contact cement to attach all of the faces, or all of the carpet to the faces. And so what I did is I had the cube assembled, and then I just went, I was worried that what was going to happen was I was going to end up with some faces switched. And at that point, I don't even want to think about what we would have had to do. And so I just started off with just the blank wood cube, and I just wrote green, green, green all around the face, and then flipped it over and it's like white, 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 to make sure that I would not mess that up, because I was really, really, really worried that I would. I'm not sure what the next slide is, but
Let's find out.
this is me sitting on it.
Yeah, we really wanted to make it such that it could support weight, and it worked. So, and it was fuzzy. Those were the 3 things we were trying to achieve with it.
So I think it's actually pretty sturdy. And so if you go forward one more slide, yeah, I'm sitting on it, and I wasn't putting all my weight on it, and I don't weigh very much, but it was still solid. But I was a little nervous, wouldn't want all that work to go down the drain because I wanted to sit on it.
Quite a few questions here in the chat. They want to see a live demo.
See a live demo? It's 30 pounds. So he solved it yesterday, and it took him an hour and 15 minutes.
Yep.
And I think he lost about 3 pounds in weight.
Oh man, my daughter with Simone, she loves Rubik's Cubes. She would love this if she were here in the room. She's in a different room.
Were you in the Rubik's Cubes before this? Is that what?
Not really. I can solve one, but I'm not very good at it.
He's a college kid. What better thing for a dorm room than a giant Rubik's Cube, a giant furry
Yeah.
Rubik's Cube.
Some of them are harder to spin than others, especially because it can come out of alignment. But it is possible to do it.
You all CNC'd the plastic parts, right?
Yeah, this is actually all the plastic parts, and actually the bearing surfaces of the plywood itself were CNC'd. So this to me was a good kind of mix of a lot of different techniques, just traditional woodworking and CNC and then the dyeing and stuff. So it was fun.
So I have a question, since my daughter is like super into Rubik's Cubes, and one of her big things was to do them as fast as possible. So she would actually grease the innards of the inside so that it would move faster. Could you do that? Would you want to on that? If you were like really into it, because she would be like really into it and wanted to solve it really fast.
Yeah, definitely not a speed cube.
Yeah. It takes me 2.5, 3 minutes to solve a little one, and this one took me over an hour to solve.
Yeah.
And I don't think it's really that it's not lubricated. It's just if the squares aren't perfectly in alignment, then it doesn't spin. And so on a regular Rubik's Cube, that's really easy to see. But this one's covered in carpet, first of all. And also they're big, so it's harder to tell.
Yeah. And we, when we designed it, we actually built in kind of a gap between the cubes, but we didn't build in a gap between the surfaces of the bearing. So we found that out, and it was binding pretty strongly, and had to disassemble the entire thing, actually hand sand the plastic bearing surfaces to provide a little clearance to allow it to spin a little better. And it's not bad now.
So it gets hung up sometimes.
That's amazing. That really is. I love it.
Let's see if I can get
All right. Any other questions?
Yeah, somebody asked, how did you glue the HDPE together? Is it HDPE? What was the plastic?
Yeah, so it's HEP. It's none of it's glued, so it's all screwed.
Okay.
David wanted to know what the final size was of I guess the whole cube. What are the
15
final
inches cube.
dimensions?
Yeah, 15 inches cubed.
15 inches. Okay.
Yeah, so every one of these is 5 inches. Uh-oh.
stuck on the last one. Come on. There we go. Perfect.
That's awesome. All right. Well, thank you so much. That's going to be a tough one to follow.
Took us a while.
But Gabe's going to take a whack at it with an eggshell repurpose madness. Let's see it.
Hello? On the way, the fish tank background is awesome. And
Thank you.
I also caught, and also I was on here a couple weeks ago, and I got the car sound deadening bug that Isaac presented. So now I'm doing that to my car too. Anyway, so last year, maybe like a year and a half ago, I was really into like not really dieting, like trying to see, you know, if I ate certain things, how it affects my body. And I did something with eggs, and I ate a lot of eggs. And I had like a furniture woodworking mentor told me about this old like ancient Vietnamese wood finishing technique, which uses eggshells. So you take eggshells and you kind of coat the whole surface of your project with it, and then in the sometime in the 20s, French took that technique and then like revitalized it. So there's like not a lot of information on it because you like look up eggshell finish, you always get stuff on paint, eggshell finish, and you never get like the actual eggshell veneering. That's what it's called if you want to look it up. So I've taken a stab at this before. This is my second time trying it out. Can you go to the next slide, please? So I wanted to go really eggy. I made all the pots into egg shape too. So what you see here, the black stuff, it's a countertop material called Rich Light. It's like it's made of paper and some sort of resin that binds it together, and it's really heavy. But it has like certain woodworking properties to it. Although it's like really difficult to work. I like using it for furniture bases so that I can make the top kind of bigger than what would normally seem possible because the rich light is so heavy. So the black stuff is the base, and then the plywood you see makes up the top. And then there's a piece of carbon fiber on the side that makes up the column. Oh, by the way, this is a coffee table. Forgot to mention all that. And then there's 3 of those long bolts that kind of pull things together. Okay, next slide, please. All right, so I saved up like 240 shells. What I did was every time I ate eggs, what did I do? I would crack the egg, cook it, and I would like, before the egg was done cooking, I would have done washing the eggshell out, and I would just kind of throw it in a bag. I ended up using only about like 36 eggs on this project. So you don't really need that many eggshells. So this section, so this is the whole surface, and I did this on a piece of masonite. Let's see, piece of masonite, and then I spray glued on there, and then put a piece of craft paper on top of that, and I spray glued the craft paper, and then I put the eggshells on. It took a long time to put the eggshells on. You just like take one eggshell and you kind of flatten it. You take a tweezer and you try and flatten it more, but it's always somewhat circular, you know. Like it never gets flat, and that'll show up later in the finished project. And you know, when you crack an egg, there's this membrane on the inside. If you ever try to do this, I would recommend taking that membrane completely off. It takes a little bit longer. If you leave it on, you have to sand it off later. And the eggshells themselves are, you know, they're not flat. They're always like a little bit rounded. And you try to sand that membrane off afterwards. You can't get to it because you have to do it by hand, which is what I end up doing. So next slide, please. So I don't have a lot of good process photos, but the first time I tried this, I used epoxy on a really small piece, and I laid down the eggshells, and then I would pour epoxy onto it, and then like quickly flip it onto my substrate, which in this case is plywood. But I didn't want to spend a lot of money on epoxy, so I ended up using water-based finish. And I did some math, and I just brushed on water-based finish onto the eggshell that I put onto the piece of craft paper, and I put on 12 layers, which took like a day and a half, because I just put it on and then let it dry, and then put another layer on. So 12 layers was about enough to fill up the thickness eggshells. Next slide, please. Oh, and I wanted to have like the spaces between the eggshells to have some sort of cool looking outer space pattern. So I had some blue dye and some like gold colored dust, and I just kind of sprinkled it on, and while the water-based finish was still wet. So it kind of just created this texture to it. But I ended up seeing it most of the way because I had to clean up the eggshell membranes. So next slide, please. All right, so this is so after I did all the finish, I put many layers of finish onto the eggshell, and then on my final layer, let's see right here. On my final layer, I put water-based finish onto my eggshells, and then I put water finish onto my plywood substrate, and I quickly plopped them together. And then when I was at this, I was doing all this at, we have a really big vacuum press, and so I just quickly carried the whole thing into the press. That like compress all the air bubbles out into two. And so after a lot of sanding, this is what comes out. What came with the tabletop, the coffee tabletop. Next slide, please. So you can see the base down there, and I was getting into wood sculpting, and so I kind of just built up a layers and an angle grinder with some sort of grinding wheel, and then eventually some sanding where I just kind of sculpted this shape out. And then there's a piece of carbon fiber tubing, that's the column in the middle, and there are bolts that go from the base to the top, that screws in there. And it ended up being really sturdy because I used 3 bolts, and it wasn't sturdy enough. I could tighten it a little more. Next slide, please. So this is a more close-up shot. Next slide. Another one. Okay, next slide, please. Yeah, so like as you can see, I put the blue dye in on the flare of water base, and it ended up all just being sanded away, or most of it was sanded away. So if I was to do this again, I would probably put the dye in on the very last layer, so it's on the very bottom, and I would end up being able to see it. Next slide. And this is just a shot to show the 3 bolts on the bottom. And I think that's it.
Wow, that is awesome. That's really, I love that, and I love the way that you put the different colored eggshells, all around, in kind of mimicking like the egg interior itself, with like the blue in the center and then the brown ones toward the outside.
Yeah.
It was really beautiful. That's amazing. I mean, you could have stopped it at like several different points and it would have just been gorgeous.
Yeah, there are people that only do this for a living. There's like there's like less than a handful of people that cover entire doors, and that's all they do. But it's like they can get it where there's like almost no gap between the like different eggs. So it's a lot more tedious to get it like that perfect. Which, I mean, I spent 4 hours on that top, but these people spend like a month or 2 months just laying eggshells down on a table on a door. Yeah.
Yeah, I personally like it with the cracks. I think they look good. I like that.
Yeah, me too.
Oh, well, thank you. Thank you so much for sharing that with us.
Very pretty good.
Thank you.
All righty. Now we have Ryan with a plane update.
All right, am I on?
Can't hear you.
On now.
A little better.
Can you hear me?
Yep, you're a little quiet, but I can hear you.
Let me fix that real quick. There, that ought to do it. Yes, good.
Good.
Okay. My slide, please. All right. So for the last about 5 or 6 weeks ago, I introduced my plane, and since then it has pretty much come to consume just about every ounce of time that I had available to me. And so I wanted to give the cliff notes. I'll try and be quick here. So yeah, if you want to give the next slide here. Yeah, so these are the general steps that I've taken to get to the point I am now. A big chunk of what I've done has just been to get the shape right. It's gone through a number of iterations, even though it looks almost exactly the same as it did 5 weeks ago. The blending the wing into the fuselage has gone roughly, but it's now basically one piece, which makes modeling a lot nicer as opposed to if you try and in CAD have two pieces that are nearly identical in shape, just butting up against one another and try and turn them into one piece. There's a whole lot of hell that you will face that I had to go through the hard way before finally figuring out that I should just make it all as one piece in the model. So that came along with just cleaning up the geometry of the modeling. You can see the lines are a lot cleaner than they're a lot cleaner than they were. Yeah. So next slide. Yeah. So one thing that's going to be very important with this project is the ability to simulate various forces that are going to be put on the craft and be able to design properly such that I understand when the various parts of my plane will fail. So I've been working on becoming familiar with ANSYS. ANSYS is a software simulation suite that specializes in various forms of physics simulations. So these are a number of different projects that I've undertaken. At the bottom right there is my my aluminum bar, where I was just and also in the middle there, I took an aluminum bar and clamped it in a vise and calculated exactly how much force it would take to make it fail, and then made it fail, and it was really satisfying. Top left there is a bridge building competition that I've entered, and hopefully that wins me that context. And then on the bottom left is a bullet piercing through a steel plate. So just trying to get acquainted with different kinds of simulations and stress kinds of failure. And next slide. Yeah, so I went from just having a solid fuselage to figuring out where all of my windows were going to go and which parts would be structural and how I was going to make the skeleton of the airplane work. I put or I modified my design such that at the top there, where the pilot's head is a hard point that can be used for a number of different things. And next slide. Yeah, among the kinds of simulation I was doing was also what's called CFD design. It's computational fluid dynamics. Basically, part of the process of iterating on the fuselage shape was to make a fuselage that looked right and then run it through this whole process of wind tunnel testing virtually and see where the pressure points were, see where I was hitting drag. In this photo, this is actually not pressure, it's velocity, but you can see the blue areas right at the tip there. Those are the kinds of areas that you would want to minimize because that's slowed down air, which generally corresponds to higher pressure. And as you can see, it's been pretty minimized. You can only really see it right at the tip of the nose and at the front of the engine, which will not actually look like that. So yeah, going from where I was, which was maybe a high school lab kind of a wind tunnel simulation, to now this is full-fledged engineering with SimScale. Has been quite a learning curve and has taken up a lot of my time the last few weeks. Next slide. And finally, we have the landing gear. This has been this is a tricky one, and it continues to be a tricky one. I'm not sure that this is the final shape of the landing gear, so I'm very eager if anybody has any feedback or any hot takes. The design I'm going for is a bit unconventional, and I'm only aware of one modern aircraft that has it. I haven't mentioned this up to this point, but the goal of the plane is to be somewhat of an expeditionary vehicle, and as such, it is an amphibious plane. Well, I started out doing what's called a flying boat design, which is basically where the bottom of the hull or the bottom of the boat is a hull and is the same as the bottom of a boat hull. But there's a number of problems with that. It's heavy and it's generally not streamlined. It's not aerodynamically efficient. So there is one plane out there that's right now that's called the Lisa Akoya, and what it uses is what are known as hydrofoils. And for anyone who's not familiar, a hydrofoil is, you could think of it as a water wing. It literally flies through and or on top of the water. So what will happen is this plane will start belly down, sunk in the water. The engine will power up and it will start going forward. And as it does, it will provide lift off of these water wings, which in this case is the first little kind of upward 45-degree angle section of that last bit right before it goes into the wheel. That is a hydrofoil shape, so that will dip into the water and lift the plane out of the water from when it will then take off. So learning how to design a hydrofoil as well as the airfoil, I found that it's really pretty transferable from how to actually design a normal wing. It is a wing. The big differences come in terms of cavitation and ventilation. So there's a little bit of difference there, but I won't go into that now. And the other main thing is that it has to be able to, or I would like for the structure that is providing structure for that hydrofoil to be the same as the structure that provides structure for the wheels, which has been a bit of a design challenge, and I'm still working through it right now. But the big question I have at the moment is making the shape, the general shape of that whole structure correct, because I haven't seen any other craft that do it this way, but there's a good number of reasons that it seems like it should be able to be done this way, and that it can be done very efficiently and very smoothly. Next slide. And yes, it will have an engine, Joe. This will be a Part 103 ultralight, so it will be able to be flown without a pilot's license. It needs to be under about 240 pounds. And yeah, so the next steps on it are I'm going to be doing more of those stress simulations, but now the big challenge with it is that this plane will be entirely made of what's called a carbon fiber monocoque. And a monocoque is where the outer skin of the fuselage or the wing provides the structure. So the difficulty with that is that that makes it a thin wall carbon fiber composite structure, which is quite another level of difficulty to model accurately when it will fail. So that's what I'm working on currently. Along with that laminate design, I need to figure out, well, I need to engineer where the carbon fiber laminates will go, because different portions of this plane, the skin that you're seeing right now, inwardly will be different thicknesses. You could think of it as stacking paper mache and having more layers at stress points. So I need to figure out where those stress points are and how much carbon will it take in order to provide sufficient structure, and how much that will weigh, and weigh those pros and cons. And after I've got a feel for that, I plan to start making the model, which should be coming a lot down the pipe, probably in the next month. I'm going to start thinking in terms of that. I haven't quite figured out if I'm going to do a very small scale with, say, a 3D printed version, or if I'm going to go straight to probably like a 20 or 25% scale model, because it's very important, particularly with the rather novel nature of the hydrofoils, that the model fly as closely as possible to the real thing, and the only way to simulate that is with size. Oh, and I need to figure out where and model the control surfaces, the flaps, the rudders, the ailerons. And yeah, that's pretty much it. I just wanted to give you guys so that's me touching base, and probably the next time I come and talk about it, I'll be starting on building the model.
Wow, that is such a big project. There's so many things involved in making an airplane. You've really taken in a lot here. This is really good work.
Thanks.
Oh, I think Rob was asking, when you make the model, is it going to be an RC model so you can test it out? Is that how that's going to work?
Yep. It's going to be so whatever model I make and however I make it, it will be a fully flyable, fully operational scale model. The final one will probably be in the 6 to 8 foot wingspan range. It will be line of sight. There will be, I won't. I actually hadn't thought about putting my my FPV gear into it, but now I have to. Probably FPV to start with, and then, or sorry, probably line of sight to start with, and then maybe FPV afterwards for fun. But yeah, the first one will probably be plastic or something like that, and then the second one I'll probably do a full carbon fiber layup and all that with a gas or glow fuel engine in it. And I think that's it for me.
Well, definitely we need to have footage of flight tests. That will be awesome.
See you guys next time.
Thank you. Yeah, thank you. All righty. And to round out the night, we have Tim H. with Blacksmith Forged Knives.
Okay, if you can go to the first slide. Right, there's a place in Gatlinburg that my family and I went a few years ago, and you can make a railroad tie knife, horseshoe knife, I think a wrench, a few other things like that. And my nephew and I picked the railroad ties. My mom and my sister picked the horseshoes, and we just had a lot of fun doing this. They actually hold the piece of metal while you're making it, and you just hit it with a hammer on the anvil, and they kind of direct you where you need to do it. But everything that you saw there, we actually did shape. We just don't get to hold the actual hot metal. it takes remarkably little time because they're basically doing this as, a business. They just want to get people in and out as fast as possible and have a little fun family experience. My nephew and I, we kind of made it a little competition where we were just wailing on the hammer as hard as we could, as fast as we could. And then my mom gets up there and it's like, tink, 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 tink. It was extremely funny. But we enjoyed it. And I went back later for a private lesson where you got to make any knife that you wanted. And if you'll advance the slide, please. And this was the one that I made during the private lesson. It took 2 days. This was completely hand forged. We didn't use anything except the grinding wheel, or not the grinding wheel, but the belt sander to sharpen, and everything else was done completely by hand. This is Damascus steel. I think it was 60 folds, and it was just all hammering for 2 days straight, and it was a lot of work, but at the end of the day, it was also a lot of fun, and it made me want to eventually have a forge here at my house, but those are not exactly easy to set up and run where I live, so I've had to kind of put that on hold. But now that we're hopefully getting one at Knox Makers, it'll be a lot of fun to go back into that. But that's pretty much my project.
Wow. Now I have a question there about that. Is these marks on it here, it looks like that's from like a hammered finish. Is that from the hammered finish, or is that artifact from the Damascus steel?
Nope, that's actually the hammered finish. I had the option of hammering it much flatter and grinding it down to a nice smooth finish, but since I had spent 2 days working on it, I decided I wanted to leave it with a hammered appearance.
Oh man, I'm glad you did. I think that looks great. I love that. I love that irregular texture. It just looks really good.
Well, thank you.
All righty. Wow, what a night. Man, you guys are amazing. Okay, and now we have some announcements. We have some classes coming up. So for those of you who are interested in learning a little bit more, we have a couple of electronics classes. This is one. I got to admit, I'm really not sure exactly what this one is about. But if you're the right person for this class, you know exactly what this is, and maybe you can come back and tell me I need to learn. Got some skill gaps there. And this is our other one, which is a high voltage power supply. I think that Ray is teaching both of those, if I'm not mistaken. And he knows a lot, and so you could definitely learn a lot from him. Alrighty, and one last announcement. If you saw this and you have something that you want to share, anybody, you don't have to be part of Knox Makers, anybody, just send us an email at this address and we'll get you put up here along with all these other fantastic projects. And even the ones that go sideways, we like to see those too. It's so much about the process and learning, and you don't get one without the other. So please come, send us your projects. We want to see them. Alrighty, and we are now done.